right, I'm going to show you a couple examples of how to do graphing sine and cosine, just the basic functions of those first, and then how to deal with an amplitude change and what that means, and how to do a vertical shift. So if we just graph sine of x or sine of theta, whatever the variable is there, we're going to do this in degrees for today, for now. Okay? So it's important that we know these like basic values for sine on the unit circle. So on the unit circle, sine represented the y-coordinate or the height. And we're going to focus on these four, I guess technically five if you count this as 0 degrees and 360 degrees. Right? So at 0 degrees, the height is nothing. Right? You're on the ground level. At 90 degrees, the height is as far up as it can go, it's 1. At 180 degrees, the height or the sine value is 0. It's at that ground level. Think back to that Ferris wheel idea. Here's the ground. Okay. And at 270 degrees, our height is as far down from the ground level as we can go. So we'll say that's -1. And then back at 360, our height is again 0. So we're just going to plot these 5 points on the graph. We're going to label these angles on the x-axis. And we're doing degrees for this. And then on our y-axis, it will go between 1 and -1, right? We didn't have any other values in here besides 1s and 0s and -1s. So when we plot our points, we're just going to plot what we have. At 0 degrees, it was 0 was the height. At 90 degrees, it was 1. The sine value was 1. 180 is 0. 270 is -1. And 360 is 0 again. So this is our regular sine curve. Right, so those points are going to be really important to just know moving forward, since we're going to do some transformations on the regular sine curve. Now if we graph cosine of x or theta, we're going to do the same thing. So now cosine on the unit circle was talking about the horizontal distance, right, from the center point. So how far left and right are we moving from this center point here? So at 0 degrees, this is the farthest to the right as possible, so the cosine value was 1. At 90 degrees on the unit circle, this is shifted left and right nothing in comparison to this center, right? It hasn't moved left or right, so that would be a 0 for cosine. 180 degrees is to the far left as possible, so we're going to say that's -1. And 270 is straight centered over the center, so it's moved nothing, and then back again. 360 is the same as the 0 degrees. So we're going to plot those same points, same angle measurements on our x-axis, and the y's can be between 1 and -1 again. And now cosine at 0 degrees was 1. The horizontal distance was 1. 90 is at 0, -1, 0, +1. So here's what our normal cosine graph looks like. So it's going to be important to keep those numbers in mind. Right? So now we'll deal with what if there's an amplitude change and what if there's a vertical shift and what that might look like. Okay. So let's go ahead and do from the homework 710. Let's just do number 1. Sine, and we have a 3 in the front of it. So all we're going to do is take our regular values for sine, which I'm just going to relabel again. It's really important we label everything, as these numbers are eventually going to change. So I'm going to graph my regular sine curve, which we can look back off of that. And I'm just going to do like a dashed line just to say, oh, that's my basic curve here, but we're going to do some adjusting, right? This number in the front here is the amplitude. It's like the stretch factor, but we're going to call it the amplitude. And the amplitude is going to stretch our graph taller or squish it shorter together vertically. And what we're going to do is take the regular values that we had for the sine function, and we're just going to multiply them by 3. This 3 in the front really is the multiplication operation. So we're taking our normal values for sine, those 0s, 1s, and -1s, and we're going to multiply them by 3. So what that's going to mean is we're going to have to extend our graph a little bit. So let me get a marker that you'll see on top of this marker a little bit. So I'm going to extend my axes a little further. So when I multiply each of these y values on the sine curve by 3, they're going to change, some of them. Right? This y coordinate is 0. 0 times 3 is going to actually stay here at 0. 1 times 3 is going to move up to here at 3. 0 times 3 is still 0. Negative 1 times 3 is at negative 3. And this one stays at 0. So this one with my stars is actually the actual equation y equals 3 times sine of x. Right? So our amplitude is going to stretch it taller. Now if our amplitude was, let's say our equation said a negative 3 in the front, all of these would be multiplied by negative 3. So it will be reflected down here like this. That would be if there was a negative 3 in the front of it. Okay. Now technically our amplitude is the distance. So our amplitude is always positive. Okay. Whether or not there's a positive or negative in front of here, if we ask you what the amplitude is, it's always going to be the absolute value, so it's always the positive value, right? Because it's representing the distance between the top and the middle. This is at 3, this is at 0, that distance between there is 3 units, whichever graph we're looking at here, and the distance between this bottom and the middle is 3 units. So that's what the amplitude is meaning, okay? So let's look at one where there's a vertical shift, possibly. Let's say on the homework, like number 4. Y equals cosine of x minus 1. All right, so we're going to draw the regular cosine graph first and label all of our intervals, which are the degrees right now. And -1 and -1. Now cosine normally started up at 1, 0, -1, 0, 1. And this is just my basic cosine curve. It's not taking into account the vertical shift. So the vertical shift is we're going to see on the end of the equation by being added or subtracted. So just like we had the a x minus h squared plus k in parabolas, the k is the vertical shift, moving it up or down. So this -1 here means it's going to go down 1 unit. All of these values are going to go down 1 unit. So all I'm going to do is move them down 1 spot from where they were vertically. So this one was at 1. It's going to go down a spot, so now it's at 0. Right? This one was at 0. Down a spot is at -1. This one was at -1, down a spot is now -2, so we have to extend our axis down a little bit. This one down 1 is at -1, and this one's at 0. So this blue one is my new actual graph of cosine minus 1. It's shifted down 1 unit. Okay? So that's just dealing with the amplitude, which is the number in the front here, but it's always the positive, which stretches it. We're going to multiply our y values right here times 3 or times -3 if this question was a negative in front of it. And the vertical shift just moves our numbers up or down, whatever this constant term is on the end. If this was a +1, we would move all of these points up 1 unit from where they currently are. Okay? So we'll look at how to kind of combine those together here in another video.